If you are studying physics but struggling, the problem might not be the physics, but the mathematics behind it. Welcome to Math Physics Bridge. In this video, I'll show you key areas in physics that every physics student should master to truly understand physics. Let's first look at algebra. Algebra is a branch of mathematics that uses symbols and variables like x and y to represent unknown values. Algebra helps us to solve equations and understand the relationship between quantities. Why algebra matters? In physics, algebra is essential because many physics formulas need to be rearranged before solving them. For example, a kinematic equation v squared is equal to u squared plus 2as. You may need to make acceleration a the subject depending on the equation. Without algebra, we cannot manipulate equations and solve for unknown values. So algebra is the foundation of solving physics problems. But solving equation is not enough. In physics, many quantities have directions. So that brings us to the next topic, vectors. Vector is a quantity that have both magnitude and direction. Examples include force, velocity, displacement. Vector can be added, subtracted, or resolved into components. Why vectors matters? Vectors matters because in physics, many physical quantities act in different directions at the same time. By using vectors, we can break them or resolve them into components for analysis. To break vectors into components, we need a very powerful mathematical tool called trigonometry. Trigonometry studies the relationship between angles and sides of triangles. It helps us connect directions with magnitude using the trigonometry ratios sine, cosine, and tangent. Trigonometry allows us to resolve motion and forces into vertical and horizontal components. This makes complex concepts become easier to analyze. But physics is not just about direction, it's also about change. That leads us to one of the most important topics, calculus. Calculus is mathematics of change and accumulation. It helps us answer two key questions: how fast something is changing, or how much has been accumulated over time. The derivative gives us the rate of change. Example is velocity from position. And integration gives us the accumulation. Example is what? Displacement, area, work, etc.